Let's talk about a new data structure, and it's called a tuple. You can call it tuple, not real difference. And they're sort of built up on lists. So what I'm going to do is I'm going to list out all the functionality and features of lists, and we're going to see and compare how tuples are different. So the first thing, we know that lists are data structure. So you're more concerned about how you're storing information, not what kind of information is being stored. Next, we know that lists are a collection, and specifically they are a sequence, and they'll take on any data type, the information being stored within them. We also know that lists are iterable, they are mutable, and that they have some methods and functions that can be applied on top of them. And we love lists because, again, you have so much freedom to do all of these things because they're immutable. You can add and remove things from your list. Because they're a collection sequence of different data types, you can just store as much information you want in a single list variable. Well, contrast that with tuples here. Tuples are also a data structure. So again, you're more concerned with storing lots of information. Tuples are also a collection, and they're also sequence. Tuples are iterable. So these two basically go hand in hand. If it's a collection, it should also be iterable. Next thing is the difference where it comes in. Tuples are immutable, and then there's also a bunch of methods and functions that can be applied on tuples. Not as many as you might have seen for the lists, but there are only a few that can be applied on tuples. But here's the biggest difference. Tuples are immutable. Now, immutability is a property of strings. What that will tell you is that if I'm able to mutate a original definition of a list, I cannot do that with a tuple. So say I were to define a list L, and it had the values 1, 2, 3, 4, 5. I am very much able to do things like L.pop, which will take away its 5 value, right? And I can do things like L.reverse. And we now know that that's going to make our list, however it is defined, it's going to make it 4, 3, 2, 1. Well, if you're interested in maintaining the integrity of your data, in that case, you're going to use a tuple. So a tuple, T, is going to look like, with parentheses here, 1, 2, 3, 4, 5. So two differences now. Tuples are defined with parentheses, round brackets, while lists are defined with box brackets. But again, the main difference here is that I am unable to do the pop, or the remove, or the sort, or anything. So any of the mutating methods you might have seen with lists are not available for tuples here. And again, the idea is that I'm able to maintain the integrity of my data. So say this tuple, T, was generated by some user input, and you never want this to be changed throughout your program. So in that case, the way it is defined is the way it is going to stay for the rest of your program. I am not able to, so I cannot add anything to it. I cannot remove anything from it. And so I cannot mutate this guy. So if I cannot mutate it, that means they're immutable, and that means that this T, the way it's defined, is going to stay the same. So why do we need it? Well, the one main scope here is the maintenance of the integrity of your data. But think of it this way. This is a collection of multiple data types, right? So I am able to make a tuple T2, which is, let's say, ABC and 2 and then 3.5, right? Well, think of it this way, because, well, let's compare that with strings for now. So with strings, we know that strings are also immutable, but we sort of have a lot of functionality we can use with strings, right? And here's the same idea. I am able to define a data structure, so it's like a collection of information of different data types. It's just that I don't need to update it at all. Now, I can use it in a for loop because it's iterable, so I can do for I in T2, and they just give me the value, and that will basically print for you ABC. It'll print the number 2, and then the float 3.5. But again, I'm unable to reverse this. I'm unable to sort this. I'm unable to do any of these mutating methods I would be able to do. What I can do with tuples is use the length function. So I can use length of T2, and that should give me 3. That's the length. I'm also able to use the max, the min, and the sum functions on top of it. So right now, these will all give an error because you cannot find the sum of 2 different data types, or you cannot find the min and max of anything that's not an integer. So if I were to redefine my T2 here and say this is going to be actually say 1, 2, 5, you'll get the max to be 5, min to be 1, and the sum to be 8. Now, I'm also able to do something like this. I'm also able to have tuple 1 is 1, 2, 3, and tuple 2 is 4, 5, 6. And one cool thing I can do is I can make a new tuple out of it by adding the first 2 tuples. Now, this doesn't mean take the numbers and sum them all together. Instead, what it will produce is that t underscore 3 will become 1, 2, 3, 4, 5, 6. So I'm still able to use these sort of a concatenation function here to be able to merge the 2 tuples together into 1. And I'm also able to take a list, a tuple, and multiply it by a number. And again, just like strings, what multiplying by a number means is that it's going to repeat your tuple 3 times. So you're going to have 1, 2, 3, 1, 2, 3, and 1, 2, 3. So where do I use tuples? Well, usually what I will do is say I have asked the user, so I ask the user for input, and I'm storing my information. So I'm storing my information in an empty list. So think of it this way. I mean, you've seen this idea of, let's say you define a list, and then inside a for loop for I in range, let's say 5. So I'm going to ask the user 5 times. I'm asking them to give me an input, right? And I'm storing it in, let's say, J, and then I'm adding J to my list. So say after all of this, my list L becomes 5, 6, 7, 8, 10, right? So once I'm done with that, I sort of need to make sure that this list is never modified. And if I need to make sure that the list is never modified, what I'll do is I'll say, okay, I'm going to make tupled L, and that's going to be tuple function of L. So again, this is the constructor function. And what that'll do is tupled L will sort of look like this. So tupled L will look like this. Will become 5, 6, 7, 8, 10. So now tupled L currently contains the user input, and I will never be able to make changes to it at all throughout my program. Now that's just one reason behind using tuples here. The second one, the second big one, is that tuples are faster in processing. Information, processing code, stuff like that. Think of it this way. If I have a list, 1, 2, 3, and so on and so forth, and if I have a tuple, 1, 2, 3, and so on and so forth, let's say it goes all the way to 10, goes all the way to 10. For this list, I can modify this, right? I'm able to modify this because it is a mutable data structure. Well, this is immutable. So the way these two are stored in memory, is that if I were to define this list here, it's going to slot in here, and because it's a list, it's going to have a bunch of methods that you can use, right? So method 1, method 2, 3, 4. So you have more information being stored here about this list compared to a tuple, where you know that you're never going to update it, so that's packing a little less information with it. And so if we are trying to process a lot of data in a list which can be modified, it's going to be a slow process compared to a tuple, which is not modifiable. The processing through it, so reading through all the elements or multiplying them all together and doing stuff like that, is going to be a little bit, going to be relatively faster, and this is going to be relatively slower. So all in all, think of tuples as lists, but lists that cannot be modified. So there's still a data structure, there's still a collection, a sequence, order matters, and they're a collection of different data types. They're also iterable. You can basically combine them together, two of them together by concatenation. It's just that you cannot modify them. So if I were to look at that example of trying to ask the user for an input and then store that in a tuple, what I'll do is I'll say, okay, I'm going to ask the user 5 times. I'm going to define an empty list, and let's also define a for loop for I in range, and let's say 5 times. I'm going to say, okay, j is an integer value of asking the user for an input, and where I say, please give me a number. And as I receive a number, I'm going to append it to my list. And what I'll do is I'll print the list, and then I'll define a tuple t, where I'm going to use the tuple function and pass L to it. And then I'm also going to print the tuple t to you. So we run this code, give me a number, let's say 1, 2, 3, 4, and 5. You'll notice that this thing is being converted into a tuple here. So I'm able to do L dot. So let's actually do that here. So after we've defined them, I'm going to move the print function down here, And let's try to do L dot append 6, right? And let's run that code and see what happens. So 1, 2, 3, 4, 5. Okay, so one thing you'll notice that the copy logic here is sound. So the tuple T is not in any way related to the original definition of L. So if I'm adding new things to my list, it's not being impacting. It's not going to impact my tuple here. And let me try to do T dot append 6, right? And what would happen? 1, 2, 3, 4, 5. You'll notice that tuple currently has no attribute. So Python hasn't even defined any methods for these methods, the modifiable methods for tuples here. Though I can do other things. So let's say I can define another tuple. I can define it this way. I can do 1, 2, 3, 6, 8. And I can do new tuple is the sum of these two tuples. If I were to run that code, 1, 2, 3, 4, 5, you'll notice that this plus sign again is a concatenation between two collections here, and so it takes the values of the elements of one tuple and combines them with the other, and you get a new tuple out of it. I'm also able to do, let's do times 3 here, and in this case this is repetition, and so if I were to run this code now and give it these values, you'll notice that 1 through 5 is repeated 3 times. Pretty cool. Now, another area where you can use tuples is when you're storing information and you can just do comma separated values. So let me do 5, 6, 7, 8, 10 here and print T for you. And run this code. We don't need these values going in, but you'll notice that you didn't even actually need to define parentheses here to sort of grab what's coming out here. Now, when we learn about functions and make our own custom functions in Python, usually the idea behind functions is that you're only able to return one value at a time. Well, I mean, it makes sense when I do, let's say, I use the power function in the math library, it only gives me one number back, which is the powered version of inputs. And so if I want to return multiple values from a function, I can, by default, just return everything in a tuple, and we can leverage information out that way. Finally, I just want to go over a little bit about the very basic idea of tuples here, and so you go back to adding parentheses, and let me tell you the length of my tuple, the sum of my tuple, and let's also do the max of a tuple. Run in a for loop, I t print I. What I'll do is I'll add a print statement here, which will be running t in loop, and also slicing and indexing. So you can also do t box bracket, let's say -1, which should give me the last element, which should be the number 10, and I can also use the thing, so I can do 3. So give me index 0, 1, and 2 elements. So you get the length, which is 5. You get the sum, which is going to be 36, so the sum of all numbers. The max number is 10. I can run tuples in a for loop, so that's not going to be a problem, and you see all the elements being printed. I can also use tuples for indexing and slicing, and so the last index, the last element, so at index -1 is this, and then I'm saying give me index 0, 1, 2, so 0, 1, and 2 is 5, 6, and 7. So in summary, tuples are cool in that they're very much identical to lists, just the fact that they are immutable. So you're still able to store information from different data types. It's just that later in your code you won't be able to modify that information. If you wanted that sort of integrity held up for your data, I suggest you go for tuples. Next, we'll talk about sets in Python. Now, sets very much act like the sets you might have heard about in math. So the idea here is that they're still a data structure, and you're able to store multiple information. So they're a collection, multiple data types goes in here. Sets are iterable. They're kind of mutable. So you're unable to modify a pre-existing value in a set, but you're able to add or remove things. And then sets have their own methods and functions you can apply on top of them. But when I say sets are a collection and they're iterable, take that with a grain of salt, because they're technically unordered and unindexed, which means that order doesn't matter. So when you define a set, you won't know it's going to be defined that same way in memory. So it is a collection. So when you define a set with 3 items, it's going to still remain with 3 items. You just don't know where each item exists. And because sets are unindexed, the iterability basically means that you can use a for loop on it, but you cannot use indexing, or slicing on it. So you're not able to use that functionality. When I say sets are mutable, again, I mean that you can add and remove things, but you're unable to modify a pre-existing element. You cannot, because there is no indexing, you can't really say, oh, change index 0 to like 5. That's not possible here with sets. Sets that have their own methods and functions, there's a long list. We're going to talk about a few of them, but again, the idea is that they are unordered, unindexed, so the best way you can use them is for maybe actually using them for just like math sets. So you could have 2 sets with a bunch of numbers, and you want to see what their union, intersection, and difference is going to be. These are methods that currently are defined for sets. One usage I have found over the years for sets is that because they are unordered and they will only contain a unique, so they also contain a unique number of elements, so unique elements only. So if there is an element that's defined twice, and your set's going to be converted into just one value, if I need to look for duplicates, and I'll come back to this, if I need to look for duplicates or remove duplicates, let's say, in a list, I'll convert it into a set because it's going to remove those duplicates. It's going to make them unordered, unindexed. I don't really care where the order is. I just want the unique elements, and that's where sets really thrive. So let's look at how you'll define them and how we can use them. So if lists are defined with box brackets and tuples are defined with parentheses, we're only left with the only last set of parentheses, and that's the curly brackets. So this is how you'll define a list, a set, apologies. And so you'll do s is equals to, let's say, 1, 2, 3, the letter A, maybe a hello in there. and that is now a set. So if we look at the property that set only contains unique values, what's going to happen is if I were to define A here, so this is the definition of a set, and if I were to then run this line of code and then run print s, as soon as this is evaluated to be stored in the set s, Python will immediately remove all duplicate values. So when you print this, you're going to get 1, 2, 3, A, and hello. Now, you might never be able to be sure that this is the order you're going to get because, again, sets are unordered. But well, the cool thing that's happening here is the uniqueness comes in. So multiple instances of the same element are going to be removed, and you're only going to get one value out of it. The next thing I want to go over is how I'm able to use sets to modify them. So if I, let's say, redefine my sets to be just the letters A, B, and C here, I cannot do something along the lines of s sub 0 equals x. So if I really wanted to change this letter x here, I'm not able to do this because indexes don't really exist here. So instead, I can add and remove things. So I could do s dot add an x here, and what that'll do is that wherever set s is defined, it's going to add a new thing to it. It's going to add the letter x. And then I can run the code s dot discard a. And again, what that'll do is it's going to discard a from my set. So if I needed to change one of these values to a new value, I would have to first do these. I would have to carry out these tasks. So remove the old value, add the new value. No replacement, no direct replacement is possible with sets. I can add multiple information at the same time. So I can do s dot update. So think of this as the extend method for lists. And let's say I want to add elements G and H. So this is, I'm passing in a list with 2 elements in it, and say after this line of code, so after this line, I'm executing this line of code, what it's going to do is it's going to make it so that your set looks like the letter H. I can also use the pop method. Now, we know that pop for list always removes the item at the very end. Here's a problem. Sets are unordered, so you're not really sure what is going to be removed. It's more of a game of Russian roulette where you might think the letter H might get removed, but the way the set is defined in memory, maybe B is at the very end, or the C, or X, or the G. So I highly recommend to never use this because you're just leaving that to chance, more or less. I can also use sets with the in operator. So I can do, let's say I can do, this was my set right now, S is this guy. I can do something along the lines of S, say, C, S. And again, we know that this is going to be a Boolean expression. For now, it's because there is a letter C in here, this is going to evaluate to true. And again, I can check B not S, and that's sort of me saying, does B not exist in the set? Well, it does, so this is going to give me false. Lastly, before we look at the code in Atom, I want to touch on those mathematical methods for sets here. So if I had a set S1 to be 1, 2, 3, and this one to be, let's say, 2, 3, 5. So I'm able to do the union, and if you remember the union, what the union means is combine all, right? So all elements of these two. So the way I would do it is I would say S1 dot union S2. And this is going to return a new set. And what that set will look like is going to be all elements of these two sets combined together, but no duplicates again. So it's going to be 1, 2, 3, 5. Just like the union, I can do the inverse of union, which is going to be the intersect. So the intersect is sort of like, think of it this way, whichever is the common is going to come out if you think of it as a Venn diagram here. So I can do S1 dot intersection of S2. And again, the intersect is sort of talking about common elements only. And if that is the case, this will again return a new set, which will be just the common terms in both. So you have 2 and 3 common both of these sets, and that's what you'll get. And lastly, you can do difference. And difference is sort of defined as the elements of one not in the other. So elements of one not in the other. And so in that case, you'll do S1 dot difference, and you can pass S2 in there. And so what are the elements of set 1 which do not belong to set 2, and you only have one here that's the unique one in set 1, and that's what you'll get. So there are methods for sets that are more defined for how you would use mathematical sets, but there are also methods that allow you to just use sets as you would use any other data structure. But again, the idea is the same, that it's just a different way of storing information. It's just another data structure. The cool thing about sets here is that they will always store unique elements. And let's look at some example code, and we'll try to figure out if I'm able to take a list and extract only the unique elements out of it using sets. So I've defined two lists here, and what I'm going to do is I'm just going to show you what they look like if I print them out. So this is an example of how the uniqueness in sets is defined. So I have defined set 1 to be 1, 2, 3, 4, 5, and 5, but because all the elements are unique in sets, you'll notice that 5 is only repeated once, and that's pretty cool. I can also then try out the methods, math version method. So I can do set 1 dot union set 2, and that's just me saying combine everything. So it should be 1, 2, 3, 4, 5, 6. You get that. I can also do intersection. So give me only the common terms here. So you have 3 repeated in both, you have a 5 in both. So when I run this, you should get, oh, there's 1, 2, 1, 3, and 5. Finally, I can do difference. So the elements of set 1 that are currently not in set 2. So you should see 2 and 4, I think, coming out of there. Pretty cool. So now let's look at more of how I would use sets to be able to remove duplicates from a list. So if I have a user list that the user gave me, and let's say it's made up of a bunch of words here, XYZ, let's say XYZ again, and let's say I have another ABC and then ABX, right? So right away we know that in this case, XYZ is repeated, ABC is repeated, but how do you think you can remove it just by using that list? So without actually using sets, can you come up with a way to remove these elements, these duplicate elements from a list? I'm gonna leave that to you as an exercise. It becomes really easy to do with sets here, because I can do user set is a set, again, the constructor function of user list, and let me print user set to you, and you'll notice that you removed the second instance of XYZ and the second instance of ABC, and finally I can say, okay, I still need a list back, so I can do user list is equals to the list version of user set. So take the user list, convert it into a set, and then convert it back into a list. And as we do this conversion from line 5 to 6, it's going to remove all the duplicates. So we'll end up with the original list, which looks like this. So we've sort of removed all of the repeating or duplicate elements from a set, or from my list. And that's where sets really thrive.